So on page 469, you have a diagram here, and this is the unit circle. What is the definition of the unit circle? It is a circle. With a radius of 1 and center at 0, 0. Now what happens with the unit circle is we are going to look at how sine, cos, and tangent are related to values on this circle. And the way that that works is if you pick any point on the circle, and they've got a point right here, x comma y, labeled on that circle. If you have that point on that circle, you could draw a triangle with a reference angle. So how would I draw my triangle with a reference angle? I would draw a line straight down, make a right angle triangle. This angle right there would be my reference angle. Since I chose a point x comma y, that means the distance from here to here would be whatever x is, and the distance of this side of that triangle will be whatever y is. So what's really cool or interesting about this and how sine and cos are related to the unit circle, if you wanted to find out what is sine of theta? Well, definition of sine. Sine is the ratio of the opposite side over the hypotenuse. And if we look at our specific triangle here, the opposite side would be y, and the hypotenuse is just 1, because the hypotenuse is just the radius of the circle. And if we look at what cos of theta is, well, it's just the adjacent side over 1. And so what this does is this introduces one of the big ideas of this unit. Any point on the unit circle, instead of labeling it as x comma y, we can relabel it as, well, x is equal to cos theta, and y is equal to sine theta. So if you know the angle, you will know the points on the unit circle. And if we looked at tan of theta, well, tan is opposite over adjacent. And since y is equal to sine of theta and x is equal to cos of theta, a second big idea that we learn in this unit is tan is equal to sine of theta divided by cos of theta. And finally, at the bottom of the page there, it says what the equation of the unit circle is. The equation of the unit circle at the bottom of your page is x squared plus y squared equals 1. In fact, if you wanted to know the equation of any circle, because you know equations of lines, y equals mx plus b. You've learned equations of parabolas. If you wanted to know any equation of a circle with the center at 0, 0, any equation of a circle will always be x squared plus y squared equals the radius squared. And since our unit circle has a radius of 1, our unit circle's equation is x squared plus y squared equals 1. I can go back up a little bit. So with the equation of a unit circle being x squared plus y squared equals 1, and since we know that the x is cos and the y is sine, we can rewrite this equation as cos squared plus sine squared, theta, let me use thetas. Cos squared of theta plus sine squared of theta is always equal to 1. A few things about notation. When you want to square cos, like cos theta times cos theta, basically this idea, mathematicians don't like to use brackets because brackets usually mean that it's not in simplest form. But then how do we write cos times cos? Because if we were to write it just with a squared, you might not know, does that mean just the angle is squared, or does that mean the whole thing is squared? So the only way that I could for sure, with the number on the outside, show that it was the whole thing squared would be to put brackets. So mathematicians have decided that if you want the whole thing squared, you can write the squared in between the cos and the theta. And if you want just the angle squared, then you can write the squared after like that. So there's just a notation thing. So what does this mean? If you pick any angle, if you pick an angle like 25 degrees, well, with tan of 25 degrees, you type that in your calculator, you push enter. Then you go to your calculator and you try sine of 25 degrees divided by cos of 25 degrees, you will get exactly the same decimal. Every single time, no matter what angle you choose, as long as all the angles are the same. Same thing with this. Now on your formula sheet, which I'm going to give you today, on your formula sheet it's written exactly the same, just they write sine squared first. Sine squared plus cos squared equals 1. So we're going to do a little bit of mental math. We're going to pick 52 degrees. Okay? I want you to calculate sine of 52 degrees in your head. Should have like a decimal that goes on forever. Ready? Now square that decimal that goes on forever. Good. Keep that in your memory somewhere else. Now we're going to take that same angle, 52 degrees. Now we're going to do cos of 52 degrees. Get a decimal that goes on forever. In your head, square that number. Get another decimal that goes together. Now those two numbers, add them together. What do you get? 1. Okay. That's amazing mental math. Well, what have you done? You haven't actually figured anything out. But as long as the angle is the same, if you do sine squared of 52 degrees plus cos squared of 52 degrees, you will get 1. If you do sine squared of 38 degrees plus cos squared of 38 degrees, you will get 1. Later on we'll learn radians. If you do sine squared of 1,000,000 radians plus cos squared of 1,000,000 radians, you will get 1. As long as the angles are the same, so you can't do sine squared of 10 degrees plus cos squared of 80 degrees, then you won't get 1. But if the angles are the same, then you'll get 1. So what I'd like to do is turn the page to 470. You should have space at the bottom of the page. And in that space at the bottom of the page, we're going to summarize these 3 big ideas. Big idea number 1, any point on the unit circle has the coordinates cos theta, comma sine theta. Big idea number 2, tan of theta is equal to sine of theta over cos of theta. And big idea number 3. Sine squared of theta plus cos squared of theta is equal to 1. Now, if you go up a little bit on page 470, you already know about the 3 primary trig ratios. You've learned about sine, you've learned about cos, and you've learned about tan. Sine, cosine, and tangent. There are 3 more trig functions that we're going to learn about this year. So in addition to sine, cos, and tan, we're going to learn about secant, cosecant, and cotangent. And they're called the reciprocal trig ratios because that's all they are. All secant is 1 over cos. So besides secant, you can write, well, secant theta is equal to 1 over cos theta. And cos of theta is equal to 1 over secant theta. They're just reciprocals of each other. And cosecant is just the reciprocal of sine. So that means that cosecant of theta is just 1 over sine of theta, or sine of theta is 1 over cosecant theta. And the easiest one to remember which goes with which, so you have to know when you hear cosecant, it goes with sine. When you hear secant, that it goes with cos. It's the easiest to remember that cotangent goes with tangent because they sound so similar. So for cotangent, cotangent is the reciprocal of tan. And so we can write tan as 1 over cotangent. And because tan, one of our big ideas that tan of theta is equal to sine of theta divided by cos of theta, we can now say that cotangent of theta is equal to cos of theta divided by sine of theta. So notice that it just flips. Now when things are reciprocals, they kind of get flipped around. I sort of use that idea to help myself remember which one goes with which. Because secant starts with an S, but cos starts with a C. And cosecant starts with a C, and sine starts with an S. At first I thought, I wish they would have decided that the letters would go together, because then it would be easy to remember which one goes with which. But if you're thinking, okay, well, reciprocal flips things around, maybe that's why the letters got flipped around. I'm not sure why we decided on those words. Don't know the history behind it. But that helps me remember that secant goes with cos and cosecant goes with sine.